This video we will be learning about the common emitter amplifier configuration of BJT transistor with C. Now what this with C and without C means, I will be telling about this in the feedback amplifier topic. Okay. So what we are intended to do, we want to draw the small signal model of this configuration in order to get the small signal voltage gain which is most needed. Okay, so for that we will be following some steps. The first step is to draw the DC equivalent model of this amplifier. So how it is drawn, the all the capacitors are open circuited and the AC source is removed. Okay, so after removing all the capacitors, after open circuiting all the capacitors and removing the AC source, our circuit will look something like this. Now the question arises, why the hell this DC equivalent model is needed? So the need of this DC equivalent model is to find out the Q point values. That is to find out the value of ICQ, VCEQ, again various voltages VEQ, VCQ, and all other things VBQ. With the use of this formula, we will be getting the small signal parameters GM and RPI as we have studied in previous video. So this is a important thing to do to draw the DC equivalent model. I will be telling about how to calculate this thing in further video. So let's move forward. Now we have to draw the AC equivalent model after drawing the DC equivalent model. Now this AC equivalent model, how it is drawn, I will be telling about that. Firstly, the all the capacitors are short circuited. We know for AC current, the capacitor means it acts as a short circuit only. The current goes through the capacitor, while in case of DC circuit it doesn't go through the capacitor, hence it is open circuited. And in AC equivalent model it is short circuited and the DC source is removed in case of AC equivalent model. Now how the AC equivalent model will look like, I will show you. So this is how it will look. The voltage source is removed, the capacitors are short circuited. Now you can observe that here RE exists, but due to short circuiting this CE, this RE is also it doesn't comes into existence in case of AC equivalent model. Now how it helps our circuit to improve the gain, I will be telling about that in feedback amplifier topic. Okay, so after why AC equivalent model is required, AC equivalent model is the key to go through the small signal model. Small signal model to reach the small signal model, we have to draw the AC equivalent model of it. Okay, it makes it simple to draw the small signal model. So now we will be studying how the small signal model is drawn. So I'll be drawing the small signal model which is derived from the AC equivalent model. Means in small signal model also no DC source will be existing, only AC source will be existing. The capacitors will not be existing, that is they are short circuited. Okay, so how it is drawn, first of all I'll be drawing the voltage source Vi. Later on, this is the resistance, that voltage divider connection, this R1 parallel R2. It will be the equivalent of that configuration. This R1 upon R2 will be written as this R1 parallel R2. Now further we will be going. Okay, now what happens after R1 upon R2, we are having the base connection, that is we are having the transistor. Now in small signal we have to draw the hybrid pi model of this transistor. Now how it is drawn, this is R pi, as R is short circuit it doesn't come into existence, and then here we have beta into IB. Okay, it is connected to ground. Now after the transistor RE is short circuited, we have shown that here this RE is short circuit, there is no RE. Okay, now RC, we have to show the RC here at collector junction. At collector junction there exists RC, at collector junction there exists RC. So here is RC, this is RC. Okay, so in this way we can draw the small signal model of the BJT amplifier configuration, and that is common emitter configuration with Sometimes there may be some load connected like this. Here may be some load like this, RL, and it will not be available here because the capacitor will be open circuited, so DC equivalent model will look like this only. But in case of AC equivalent model, the RL will come in parallel to RC. Okay, it will come in parallel to RC, and according to that, in small signal model also it will come parallel to RC. Okay, so if you can draw the small signal model of a common emitter amplifier, you can solve any sort of numerical related to finding out the small signal voltage gain, or designing a common emitter amplifier, that is finding the values of R1, R2, etc. So in the next video I will be talking about the formulae related to all these things: the small signal model, the DC equivalent model, how to find IC, AV, GM, RPi. So I will be telling all those things in the next video. Thank you.